Number 21. A constant horizontal force Fa pushes a 2 kilogram FedEx package across a frictionless floor on which an XY coordinate system has been drawn. This figure over here gives the package x and y velocity components versus time t. What are the letter A, the magnitude, and letter B, the direction of the force Fa? So we want to find the force Fa, the vector, and we must remember that, let's remember from Newton's second law, that F is equal m times A, the acceleration. So if we can find the acceleration, we can find the force as well. So that's our strategy. We will try to find the acceleration of the package. So in these graphs over here, we have the velocity in function of time. And we can see that the velocity it's a straight line. So we can conclude that the acceleration is constant. And if the acceleration is constant, let's say the acceleration in the x direction, we can write it as delta v in the x direction over delta t. So we can find the acceleration by just doing delta v over delta t, because the acceleration is constant, because we can see it is a straight line, the graph of the velocity in function of time. So let us choose two different points. Let's say this point over here and this point over here. So delta Vx is equal to, let's say, 3 meters per second. And delta t is equal to 1 second. So the acceleration in the x direction would be 3 over 1, which is equal to 3 meters per square second. So this is the acceleration in the x direction. As for the y direction, we can do the same process. So this would be equal to delta vy over delta t. So we can choose two different points. You can choose any two different points that you want. You could choose this one, that one, anyone. Okay, so let's choose this one because it's easier. So we can see that delta vy in this case is equal to, let's see, 1, 2, 3, 4, 5, minus 5 meters per second. Let's do this in a more beautiful way. So this is minus 5 meters per second, and it has passed 1 second. So this is 1 second as well. So delta vy is equal to minus 5 over 1. So this is equal to minus 5 meters per second squared. Okay, so now we can write the acceleration in unit vector notation. So it would be the x component in the I direction plus, which is minus because we have minus 5 over here. So minus 5 in the j direction, meters per square second. So this is the acceleration in unit vector notation. So we can find the vector f now. So it is simple just multiply by the mass of the package, which is 2. So it would be m times a. Remember that m is equal to 2 kilograms. So in this case, vector f is equal to 6 in the I direction minus 10 in the j direction. And this is Newton. Don't forget to include the unit at this point. So we have the vector, and we want the magnitude of the vector. So we want the magnitude of vector Fa, and you just take the square root of each component squared. So it would be 6 squared plus minus 10 squared, and this would be equal to, let's see, this would be equal to 11.7 newtons. So this is the answer of letter A, 11.7 newtons. This is the answer of letter A. As for letter B, we want to know the direction of Fa. So the direction is given by the tangent to the minus 1 of the y component over the x component. So this is y and this is x. So it would be equal to the tangent to the minus 1 of minus 10 over 6 and this is equal to minus 59.0 degrees. So this is the answer of letter B, and that's the answer of letter A.